And today we'll discuss during this webinar how to build signal processing graphically using nCodeDS. So we'll start by recalling what nCodeDS is and how come it's so powerful. Then we'll see how to create an nCodeDS process graphically. We'll then share an nCodeDS process using an app with no coding, making it very easy to use for the non-expert user. And I'll illustrate all this during a live demo. And we'll end up with a Q&A, question and answer session. Allow me just to introduce Prencia, which is the software arm of HBK. So Prencia help engineers deliver durable and reliable products and avoid the cost of unexpected failures. We are the editor of two software brands, nCode and ReliaSoft, but we also provide training, services, and solutions. So in terms of the software portfolio, the very left column here shows tools for reliability analysis with failure data analysis, test planning, system modeling. Then the next column is about reliability management. So here we want to manage the risks, the maintenance, manage actions. And then we fall into the nCode software tools. So we got here Design Life for CAE-based durability, the analysis of measured signals with GlyphWorks, the noise and vibe analysis with VibeSys. The last column now contains the data management tools, and this includes Aqira, which offers a web portal to access the measured data and the various nCode tools. So we will concentrate on Aqira and on nCodeDS, which is Aqira's native analytics engine. So what is nCodeDS? nCodeDS enables engineers without any data science expertise, and those engineers who are overwhelmed with sensor data, it enables them to gain actionable insights, right, from using a high performance data analytics. nCodeDS is provided within Aqira, which means it's easy to deploy and it makes it scalable too. We'll see why. So what is it used for, typically nCodeDS, and what are the requirements of nCodeDS, right? Let me start with the quantity of data. So we get more and more data due to the widest availability of data, due to the affordability of sensors and storage. There's also a variety of data. So not only do we get the high precision sensor data coming from traditional DAC hardware, but also we get data coming from a vehicle CAN bus, for instance, or from the connected equipment like Internet of Things, and we process the data. We have to process data coming from monitoring applications, and most of this data is or can be, unevenly spaced in time. It contains not necessarily only numeric data, but it can contain strings and, generally speaking, not a number values. So we have to cope with that, right, to deal with that. There's a need for speed as well. So we want to make full use of the modern computer's power. So we need something that's thread safe, something that's distributable, something that's just really quick to run, sensitivity analysis and what ifs and things like that. So here we've got the 3 V's of the big data world, the volume, variety, and velocity. And I'd like to add a 4 input bullet point to that list. So it's the need for engineering analytics. So we want something that's dedicated to engineers as opposed to the general purpose data analytics tools. So we want it to be very specific to time series, and with the signal processing features, digital filtering and frequency spectrum, and but also counting histograms and rain flow cycle counting, fatigue damage, etc. Everything an engineer needs in his engineering applications. So why is it that nCodeDS is so powerful? Let me run a little animation here. So nCodeDS, its framework uses streamed processing and multi-threading. The data is streamed through the network in frames or chunks of data. Let me start it again so you can see. So that's a network with its various processing nodes, processing network with the processing nodes, and as we said, the data is sent as frames to the processing nodes. Each node operates on the data as soon as it gets it, making it highly parallel. And this framework enables it to be extremely efficient, and especially when crunching huge data sets. Now, some of you might use nCodeDS already in Aqira. It can be used through the Python runner app component that you can see here. And using this component, we can call the nCodeDS functions in Python. And this scripting capability, right, in Python is very versatile. It makes it very versatile, and it enables you to create a processing network with additional, including additional Python modules such as NumPy or scikit-learn if you want to run some machine learning, for instance. So it's very powerful and versatile. So how does it look in practice? How does it work in practice? This is an example Python script in the Python runner. And you can see here, for instance, that we set up an arithmetic node with some of its arguments here. And you can see here that we connect all the nodes and we create a so-called processing network. And then you've got the run function below. So that's how it runs in Python. Now that's how to create now an nCodeDS network graphically. We've got in Aqira 2021, we've got this new app component called nCodeDS. And this component offers you a canvas and a palette of nodes. And you can simply select a node of interest, drag and drop it onto the canvas. And if you click on it, you access the properties. You can set up some properties of this node. You do the same with other nodes. You connect them. And there you go. You've got your nCodeDS network, which is represented graphically. So no coding was required, simply drag and drops and modifying properties if required, right? Now, there's nothing stopping you from creating a complex network, right? If there's a need for multiple branches and a large number of nodes, you can end up building a network like this one, which typically requires quite a few inputs from the user. For instance, here we get a filter. You might want to let the end user the ability to change the cutoff frequency. We've got a fatigue damage node here. You might want your users to be able to set the slope of the SN curve, for instance, right? So since those users that you're building this process for, say, are not experts and all they want is a quick, rapid access to those very properties. So you want an easy to use front end onto that, right? For non-expert users to be able to use this network. So that's what an app can help you with. So you can create an app so that it asks a few questions that are relevant, like select the input files you want to use in this network. Then the customer clicks next and accesses a list of properties that you as the author have exposed to him or her. And therefore you may hide all the options that are not relevant. And most importantly, it provides eventually a graphical results and enables your user or your users to focus on the results, to focus on interpreting the results as opposed to spending time understanding how the author constructed the network in order to modify a property, for instance, or what. So that's really the power of apps. Easy to share, easy to collaborate throughout your organization with very simple use, right, of something that could be very complex in reality. So if you had to remember just three points out of nCodeDS, I would say, it enables you to extract more value out of huge quantities of sensor data. And by sensor data, I mean something coming from a traditional DAC system, data acquisition system, right? Or coming from a digital bus, or coming from a big data repository, storage, whatever kind of storage, right? You want to extract value out of that. It's very powerful and scalable. It's high speed due to its framework, as I illustrated before, and it's got dedicated algorithms for engineering applications and for durability, particularly. And then it's easy to use, easy to share, easy to use because now we've got also this graphical interface. In addition to the Python interface, both interfaces exist, right, for running an nCodeDS network. But the graphical interface makes it even more accessible. And the fact that it's embedded within Aqira makes it easy to deploy, as we just discussed, right? And easy also to share the data and the results, etc. So time to move to the demo. Before that, allow me just to explain you what I'm going to show you. First, a little story. What is it I want to achieve? So I've got loads of CAN bus data, say in CSV, so text format. This data is unevenly spaced in time, and it contains missing values like gaps and pieces of strings here and there, and generally speaking, not a number, not nans, right? And I want to create some data processing network to clean it up, first of all, and reduce this this huge quantities of data into stats and histograms, for instance, that are far more speaking, right? That enables me to draw conclusions in a much easier fashion. So I want, and eventually I want to share it with some of my colleagues who are non-expert users, and I want them to be able to run it on their data and focus again on the results to make some conclusions, decisions, see the trends, see the effects of some change, on the results. So that's my objective, right? Now the challenges I have is like, I'm an engineer. I'm not a data scientist. I'm not a Python expert. So how can I create an nCode data processing network using this new graphical interface? And how can I create those easy-to-use front ends? And how can I deploy a validated and version-controlled app so that my colleagues throughout my organization can use that safely and focus their time on interpreting the results again? So I'm going to show you how to create a processing network graphically. Then you will encapsulate this into an easy-to-use app. And we'll run that app and display the results, right? So let me do that for you now. So I'm in Aqira. I've logged in, and I've clicked on my app list. I see here a list of apps that I created, or some other colleagues of mine have created. Let's start with cleaning up the CSV data. In other words, turn the nans into numbers. So let me focus on the guts of this app, and let me go really radical here. We'll very quickly we'll create it from scratch really quickly. So let's start with the nCodeDS network. You remember that's the app components nCodeDS that I can use to access the the graphical interface, right? So this is a very simple app that we will create. So I'm going really fast. So we need an input node, we need an output node, and in the middle, we need something that addresses the nans. So we get several choices here, the most obvious ones being the drop nan node, so for dropping the nans. But I don't want to drop them. I want to interpolate or substitute the nans with real numbers. So I'm rather going to use the fill nan node. Now I need to connect these together. And if I click on the fill nan node, I see its properties. So they're not many methods, constants. I wonder what this method is. So what you can do is click here and access the help. And here what we see in the help for the fill nan node methods, and there you are. So that's the help for the methods. And you see that it's a comma separated list of one or more methods. And by methods, we mean interpolate, backward fill, forward fill, replace. So, interpolate would be the one I'd like to use, but actually what happens if the nan is at the very beginning or the very last end of my file, right? It's got nothing to interpolate with. So that's why the forward or backward fill can be useful. And look at that. The auto option, which is my property, is equivalent to using interpolate, then, if not possible, forward fill, then, if not possible, backward fill, and if not possible, replace. That's great. That's what I want, right? So I'm not going to touch it. That's fine. That's my network. One thing I'm just going to do is change the name of that output node, and you'll understand why. Let me call it clean data, right? Beautiful. Clean data in outputs. I'm validating it. All is fine. Done. So now I want my users or myself, if I'm using it, to be asked the question, what files do you want to use in this network? So I'm going to add a file selector on top and make sure that the nCodeDS input node connects to this file selector. Just a little bit of wiring to do, but nothing complicated. And by the way, that the interesting thing is to look at the data before and after, right? So I've got a nice table viewer. Let's interlace a table viewer here. So that's to display the row data, and another table viewer after my nCodeDS process. So that's to take a look at the clean data. That's why I renamed the node. It's nice and easy to spot it in this list. I think I'm done now. Let me validate the app, save, and now we're going to run this very simplistic app. So let me press the run button here, and it should ask me what file do you want to use for this very app. Sorry, it takes a second here. So let me grab this CSV file, for instance. I'm selecting this one, and I click Next. And here's the first table display. And I see indeed there are nans. Let me change the number of columns here. Let's go to 9 columns, for instance. So indeed, I see nans here in the vehicle speed column. I see nans in other columns as well. And also another observation is the time vector. It's highly unevenly spaced, isn't it? By the look of it, like here from 1 second, it jumps to 1.5, and even worse here over a second gap. So highly unevenly spaced, and some of the values are not defined, right? Are not numbers. Now, if I press next, that's where the processing is taking place, and now it's showing me the data after anomaly correction, right? So easy to see that there is no more nans, right? Here it's probably applied the backward fill, and here I guess it's applied the interpolation. So great, I've got now my data ready to be processed, ready to be sent into a histogram or whatever other engineering calculation. So that was just a very simple example of a very simplistic app that we created from scratch, including this new graphical design of a network, of an nCodeDS network. Just the second phase of my demo is to show you now a more realistic app with a more sophisticated network. So those are the components of the app. So we recognize the same file selector here. I've got viewers in the end. In the middle, I've got this nCodeDS component. Let me just take a look at what it looks like. Here it is. So it's you could see it, you could think of it as the continuation of what we did previously. So you got an input, a fill none node, and then I continued with I decided to separate this vehicle speed channel from the rest. So here in this node, you've got a condition, and I decided to isolate the vehicle speed column or channel from the rest, and all the columns that pass the condition are in this output here. And so where does the data go? It goes in a time at level distribution here and gets saved. So how much time have I spent in various speed ranges? We can quickly look at the properties. So I want 14 bins with 10, each bin being 10 kilometers per hour wide in this case, right? So it goes between 0 and 140 kilometers per hour in 14 bins in this very case, right? But the other interesting thing I do is I convert the speed units from kilometers per hour into meters per second, and I'm integrating it. So therefore, in this pipe here, we've got the distance-driven signal, cumulative distance-driven, right? The integration of the speed. I'm merging it with the speed. I'm saving, but I'm also doing something really interesting. I'm swapping the index so that the data, those columns are not considered versus time anymore, but versus something else. And in this node, I've told it to consider the data versus the cumulative distance driven, so that the same histogram as I used there that gave me the time distribution, time at level distribution, is used here, with the difference that in this time it's computing the distance driven for various ranges of speed. That's the sort of engineering analysis we can do with nCodeDS, right? We've got all these nodes that are available to you that you can use and combine and create your pretty sophisticated analysis, right? So now that it's done, validates, done. The other component here, which I've not covered yet, is this custom page. I won't enter into details, but this enables you to expose some of the properties outside of the network, so at a higher level. Let's make it a more easy for you to understand. Let's just run this app. So it's gonna again ask me what files do you want to use in input. I'm gonna pick a CSV file, and we're gonna run it through the network. So let's take this one next. That's the custom page, you see. So you design this page the way you want. You position all this text the way you want, and you ask the questions you want, and the answers to the questions will drive the analysis that's running next, right? So here, the fill none method, we know what it is, right? You can pick and choose. I could have gone with replace, in which case it asks me what value do you want to use as a replacement, right? But let's leave it to auto. The other thing is that you want a cumulative histogram or non-cumulative, right? Discrete histogram, and other properties that you can add there. So making the use of this app that easy for even the non-expert user. Let me press next. So that's where the processing occurs. So the nice graphical workflow that we saw was used for processing the data, and that's one of the displays. So it shows the vehicle speed signal, right? You see in kilometers per hour versus time. So my trip lasted 500 seconds, and here you see how the speed fluctuates. This signal used to have nans in it, but we've corrected all the nans, so it's a nice and smooth signal that we could use in calculations, and that's what we did. We integrated this signal, and we obtained the blue one, which is the cumulative distance driven, and we see that after 520 seconds, we've driven 7.7 kilometers in this very case, right? So that's one output, quite interesting. And the next one are those histograms now. So I've got two histograms that are displayed side by side. I can display them separated or overlaid. In this case, the red histogram is the time at level. So how much time have I spent in various speed ranges? So I spent quite a lot of time between 0 and 10 kilometers per hour here. Right, and less time at high speed. And the blue one is the distance driven. So here in this case, again, we see that we've driven a very little bit at very low speed and more at the mid speed range, and quite a bit of distance at beyond 100 kilometers per hour or whatever. It's easier to draw conclusions from 14 bins histogram than from the original raw data, right? So that's a very condensed way of looking at one particular statistics, which in this case is the distribution of time spent or distance driven versus various speeds. I think that's mostly it in terms of the demo. So say you're happy with this data reduction app, you're the expert of customer correlation within your organization, and you want to share that to your colleagues across your organization. So what you can do next to finalize it is share this app, and you can share it with all the users or just a group of users or just individual users, right? You can add users from the list of current users, right? Search for users, etc. And then they can just run this app the way we did, right? So that was the demo. I hope it's been clear. Let me go back to the PowerPoint and summary. So you remember in the agenda, we asked, we had three bullet points. The first one was, what is nCodeDS? What's an nCodeDS network, and why is it so powerful? So we saw that nCodeDS is useful to extract more value out of huge quantities of sensor data. We saw that it can be used in Python or graphically. And we saw that it's embedded within Aqira, which makes it easy to distribute, and it's got this scalable framework which makes use of a big server you got somewhere, for instance, and remotely users can with clients can just make use of this huge computer resources. How to create an nCodeDS process graphically? Indeed, not all engineers are Pythonistas. So for them, you want them to be able to use a graphical interface. So we want it to be easy, and I hope you concluded with me that it's pretty easy to create and easy to use. And the other bullet point was how to share an nCodeDS process using an app with no coding required. So we did that. No coding was required, just a little bit of wiring between the components. And there you go. You've got your app that's easy to use, that you can share with non-experts so that they can automate the analysis and spend most of their time at doing your engineering job as opposed to understanding what someone else has coded. So they enable to encapsulate the expertise, the in-house expertise, and the intellectual property within a nice, simple, easy to use app that's version controlled, that's been validated up front. And there you go. You can share that. You can deploy that throughout your organization.